Exercise 9A, combining geometric growth and decay. What this exercise is all about is taking what we know from compound interest and simple interest and combining them all together. This is all about calculating compound interest and then making additional linear repayments. We can start by finding out what the recurrence relations would be in these scenarios. We always, as per usual, start with a initial value, which we'll symbolize here as V0. Now, if we're adding money to an investment, the way that we would write the recurrence relation would be Vn plus 1, and that equals R times Vn plus D. Now, if you remember from our previous chapter of chapter 8, D is just some amount. So perhaps it's an additional monthly investment that we're putting in. And the R value, well, that is the interest being added to it. So we could either have some growth, as we indicate here, or it could be decay. So if we're putting in an investment, then it's going to be growth. Or alternatively, if we have borrowed some money, we'd more than likely be having a growth situation. Decay would be more if it was an investment, something that was reducing in value over time. For the most part, we tend to use the 1 plus R over 100. The other situation, which we have here, we've got V0 equals initial value, would be R times Vn minus D. And this would be the idea that I'm borrowed some money. So this second one is very much like I'm borrowing money and I'm constantly making payments to try to get it down to zero. Exercise 9A.1. The value of an investment in dollars after n years can be modeled by the recurrence relation shown below. V0 is equal to 46,000. Vn plus 1 equals 1.0034 Vn plus 500. So already I can see here that this is a 1 plus R over 100. How can I tell? Because it's greater than 1. If that value had been 0 point something, then that would have been a decay situation. What is the value of the regular payment added to the principal of this investment? Well, the regular payment is the value of D. So that is the thing that we're adding on each time. So this is going to be option D, and quite aptly, it is option D in the multiple choice. So that is the regular payment. Between the second and third years, the increase in the value of this investment is closest to. So what we'll need to do is to work out what the value in the second and third years are. Now we could work this out by hand, or alternatively, we can use the sequences option. In the sequences option, I'm just going to put in the recurrence relation as stated in the question, and then work out what the values are in the second year and in the third year. So in the second year, and it's very important to click on the values so I know not to round up incorrectly. In the second year, I have $47,315 and 0.3 to 2 decimal places. So when we're dealing with dollars and cents, it has to be to 2 decimal places. And in the third year, it is $47,975.90. So the measure of the increase will be the difference between those two values. So I just need to subtract them. So we'll subtract the larger from the smaller. And when we do, We can use another calculator just so we don't lose all our things on the screen. We can go 47,975.90 minus 47,315.03, and we get $660.87. So the option that is closest to that would be option C.